I'm Anil Kumar, and in this video we will understand how to find limits of functions involving rational exponents. Here we have two examples which are very similar, and I hope they will help you to understand and implement the method. The question is to implement limit of the function where x approaches 1. The function is x to the power of 3 over 2 minus 1 divided by square root of x minus 1. The other one is similar with minor difference. Here we have to find limit as x approaches 1 for x to the power of 3 over 2 plus 1 divided by x minus 1. Now first step is always to substitute and directly see if you can find the limit. X equals to 1. So when I substitute 1 for x, I get 1 to the power of 3 over 2 minus 1 divided by square root of 1 minus 1, and that gives us 0 over 0. Now 0 over 0 is undefined. We say it is indeterminate form, and whenever you get this kind of a situation, it tells you that there is a common factor in both numerator and denominator. So once you will take care of that common factor, you can easily find the limits, and that gives you the best way of finding limits for rational function, and that is using factoring techniques, right? So you could factor and find your solution. I hope you remember the other two methods which we call rationalization and substitution. So these are other methods which could be adopted. Okay, so we'll explore more examples with those methods, but this one I prefer to do with factoring. So let's see how to factor and solve this particular limit. So we have limit x approaches 1, x to the power of 3 over 2. Now what does that mean? I find sometimes students getting confused with this. So let me rewrite this. X to the power of 1 over 2 cube. So you could think like this. Square root of x cube. Do you see that? That is 3 over 2 minus 1 divided by, we already have here square root of x minus 1. Now we will actually expand the numerator and then see what do we get. So a cube minus b cube we could adopt, right? So which is a minus b. So square root x minus 1 times a square, that is x, plus ab. So when you multiply these two, you get square root x plus 1 square divided by square root of x minus 1. And now that common factor which we are talking about can be cancelled. Once you do that, you get limit x approaches 1 for x plus square root of x plus 1. And now when you substitute 1 here, you get 1 plus square root of 1 plus 1, which indeed is 3. So in this case, you get 3 as your answer, right? Now let's do the next one also. Here again, let us substitute 1. So you get what? In this case, what you get is 1 and then plus 1 divided by 1 minus 1. Now something over 0, which is in this case 2 over 0, is also indeterminate form, right? So we can try this factoring method here also. You could do substitution or rationalization also, but I prefer such examples to be factored, right? You will soon appreciate. See, it was how simple it was. Okay, so let's continue with factoring of the given function. So we get limit x approaches 1. Now, you know, this could be treated as square root of x whole cube plus 1. So a cube plus b cube is the formula which we need to apply here. We get square root x plus 1 times a square, okay, let me write this as square, minus ab, so minus ab plus b square, which is 1, divided by, you can factor x minus 1 as square root of x minus 1 times square root of x plus 1. Now as you can clearly see, square root of x plus 1 cancels out. Substitute 1. Now when you substitute 1, let me first rewrite this as in the simplified form. So we have x minus square root of x plus 1 divided by square root of x minus 1. Now it is approaching 1. Now when you want to substitute 1, what do you get? In this case, what you get is 1 minus 1 is 0, and you get 1 over 1 minus 1, which is again 0. So in this particular case, you find that it is again of the form something which is 1 over 0. Do you see that? So basically it is undefined. So in this case, what we say is that the limit does not exist. Right. Now you could have seen right in the very beginning also, since it was not 0 over 0, so there was not really a common factor between the two which could have got rid of 0 from the denominator. The common factor which got cancelled did not really result into 0, right? So that is what you need to appreciate in this particular example. So in the case of finding limits, you may get the limit, you may not get a limit, right? At times it may be apparent when you just begin with, right? So when you started with this solution, we kind of knew that we might get this kind of a result. I hope that helps. Thank you and all the best.